Okay, in this video we're going to have a look at significant figures. So first of all, let's just see what we mean by significant figures. So here's some various different numbers, and we're going to just say how many significant figures we have. So 2.3, we have two numbers here, 2.3, so we have actually, in this case, surprise, surprise, two sig fig. In this case we have 1, 2, 3, so we have three significant figures. 1, 2, 3, 4, 5 significant figures. Here we have two significant figures. Okay, so we write 2, and here we have three significant figures. Okay, and then we have slightly more complicated examples. So in this case we've got 30. The problem here is we don't know whether the 0 is significant or not. So this could be one significant figure or two. So 1 or 2, we're not sure. The fact that, so this is the same number, it's 30, but the fact that somebody's written one decimal in here suggests that the decimal place is significant. Okay, so in this case it looks like we have three significant figures, so 3 here. Here again we can't be sure whether these three zeros are significant. Okay, we've obviously got 1, but we could have 1 or 2 or 3 or 4 significant figures. We can't be sure. Here we've obviously we've got 1 sig fig. Here we have it's the same number, but these two zeros here, the fact that somebody's written in two zeros in this case suggests actually we have three significant figures here. So 3. Now, one way to avoid confusion is actually to use standard form. Okay, this makes it very clear that's how many significant figures we have. So in this case we have one significant figure. If this number was written 2.0 times 10 to the minus 3, then we would know there are two significant figures. If it was written at 2.00 times 10 to the minus 3, we would know there were three significant figures. Okay, so a standard form is a nice, clear way of establishing how many significant figures we have. Okay, let's go back to this example here, where we're not sure how many significant figures we have. If this was written in standard form, if it was one significant figure, we would write 3 times 10 to the 3. If it was two significant figures, we would write 3.0 times 10 to the 3. Three significant figures, 3.00 times 10 to the 3, and four significant figures, 3.000 times 10 to the 3. So it's just a much clearer way of showing how many significant figures we have. Okay, when we're multiplying and dividing, we have to take into account the significant figures in our answer. So let's just show you an example. So if we have 3.2 times 5.61. Okay, let's check the significant figures. So we have 1, 2 here, two significant figures, and we have 1, 2, 3, three significant figures. Okay, if we do our answer, and we check it on the calculator. Now if we look at our answer by multiplying these two together and just putting it in the calculator, we get 17.952. Now if you wrote this down, it is incorrect in terms of significant figures, because the rule is you look at the number of significant figures in your raw data, and the number of significant figures in your answer must be to the same number of significant figures as the smallest number of significant figures in your raw data. So in this case we've got two significant figures here, we've got three significant figures here, our answer can be to no more significant figures than 2. Okay, so in this case, our answer will be, we round this up to 18. 18 obviously has 2 sig figures. Okay, just to emphasize that, we'll do another example. So let's say instead of multiplying these two numbers, we divided them. So let's do 3.2 over 5.61. We get the calculator out. So our calculator reads 0.5704 blah 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 blah. All of these numbers are not significant. As we said before, we've got 2 significant figures and 3 significant figures for our raw data. We can only have in our answer the smallest number of significant figures, so we can only have 2. So we therefore round up to only 2 sig figures, so it's going to be 0.57. 0.57 has obviously got two significant figures. Okay, now let's consider what we do with significant figures when we're adding and subtracting. So let's take a couple of numbers. So 1.532, and we're going to add on to 1.65. In this case, significant figures are less important than precision. Okay, this has a precision of, so this is measured to 1,000th, that's the 10th place, that's the 100th place, and that's the 1,000th. So this is being measured to precision of 1,000th, and this is being measured to precision of 100th. So when we add these two together, let's just get the calculator and do that. If we do the summation in our calculator, we end up with 3.182, but we don't write down 3.182. We need to look at, our answer can only be precise to the least precise raw data. So this is our least precise raw data. It was precise to 100th. Okay, so our answer could only be precise to 100th. Okay, so we write down 3.18. Okay, let's do a subtraction. So let's try a few numbers. So 3.75 plus 30.6 plus 17 equals. Okay, if we do this sum on the calculator, we end up with 51.35. But we can't write this down because this is to the precision of hundredths. Okay, and actually our least precise number is here. Okay, which is precision of ones. So our answer can only, we'll have to round down in this case. So we end up with an answer of 51.